I'm Dr. Daniel Barth, and if you're viewing this video, you've joined one of my classes for the fall 2017 semester at the University of Arkansas. You may be in Introduction to Education, Outdoor Education, Astronomy for Educators, or Introduction to STEM. In any case, I'm going to be gone for the very first day of our semester, August 21st. I'm going to be doing what science teachers have always done, going out with students and observing natural events. In this case, I'm traveling to St. Joseph, Missouri to observe the Great American Solar Eclipse of 2017. Although I've observed half a dozen solar eclipses and several on the planet Jupiter, I've never seen a total eclipse here on Earth. So I'm going to go experience it, photograph it, and enjoy it with a lucky group of students from the Springdale school system. Hello, Whimsy. Are you a good boy? Sorry, my dog Whimsy has joined us in the studio. In any case, your first semester assignment, if you're in outdoor education or if you're in Intro to STEM or Astronomy for Educators, is going to be to observe and record the solar eclipse. Now, for us here in Northwest Arkansas, the solar eclipse will reach its maximum between 12 and 1 o'clock. I'll send you an email with more precise details. What I'm going to want you to do is observe the eclipse safely, make a record of it, and turn it in as a laboratory assignment. Now, these are solar eclipse glasses, and you'll have to admit they are the height of fashion. I've managed to get a hold of a limited number of pairs of solar eclipse glasses, courtesy of the supporting STEM and Space Foundation, and I'm going to make them available to you in the main office on Monday, August 21st. I would like you to take a pair of glasses and share with a friend. I have about 40 pairs approximately, not enough for everyone in my STEM and astronomy classes, but if we share, there should be enough. I'm going to ask people who observe for me to go out and make your observations somewhere in the quad between Peabody and Old Main. That way, if there are others from our class who want to observe the eclipse and haven't managed to get a pair of glasses on time, you can share yours with them. These glasses make it perfectly safe to look at the sun. Once you put them on, over your specs or underneath them, you can go ahead and look at the sun for as long as you like in perfect safety. These are made of aluminized mylar lenses, and the aluminum coating in the mylar screens out everything but about 0.003%. Something like 3/10,000ths of the light of the sun gets through. It makes it perfectly safe to view with your naked eye. However, you may not use these and then look through a camera or a pair of binoculars or a telescope. Telescopes, binoculars, and cameras gather sunlight and focus it, and the light focusing capability of a binocular or telescope would be plenty strong enough to burn right through the plastic lenses. These are for your eyes only. So let's please be safe. These will let you see the eclipse, but how can you document it? One interesting way that you can do is you can take this pair of solar eclipse glasses and put it over the camera lens on your cell phone and see if you can take a picture that way. Now, I've never done this before. The last eclipse event I was in was in the 1990s, 91 I think, and sorry, cell phone cameras weren't a thing then. So I want you to try this and save the photo. Next, I want you to see if you can document the eclipse. To do this, we're going to use a solar eclipse projector. You can make a solar eclipse projector in a number of ways. One of the easiest ways is with a pair of common binoculars. Any size will do. If you have a pair of binoculars, or you can borrow one, then you can go ahead and take a piece of kitchen foil and put over one lens. Now this makes the binocular look a bit odd. It actually turns it from a binocular into a monocular. And we're not going to look at the sun. Never, never, never. What we will do instead is allow the sun to come through the objective lens, and then we'll take a notebook or a piece of paper and we'll hold it up and we'll project it through, and we should get a very nice image of the solar eclipse. Now, interestingly, when you do this, it takes a little practice. So if you've got a pair of binoculars and you're going to try this technique out, then I definitely recommend you practice a little bit before the eclipse occurs. Oftentimes it works best if you start very close and then pull the binoculars back gradually, and you'll get a nice big image that's plenty bright enough to photograph with a cell phone. Now, obviously, if you're holding the binocular in one hand and the paper in the other, you're going to need a friend's help. So what I'm going to recommend is please go ahead and have a friend take your cell phone, and while you're going ahead and projecting a solar image, go ahead, smile at the camera, and let a friend take a picture of you projecting the solar image onto a piece of paper. What I'd also like you to try to do, and again, this would work best with a friend, while you're projecting the image, have the friend trace out the circle of the sun's disk and the portion that's shaded or blocked by the moon. This will be your record of the solar eclipse, and this will serve as your laboratory with the photograph that you've taken. But what if you don't have a pair of binoculars? What if you say, well, I don't have one, I can't find one, I don't know anybody else who's got one either. There are a number of other ways you can do this. I've got here a can of breadcrumbs. I picked this because, frankly, the container is made of cardboard. I was able to modify it by taking a pair of scissors and cutting a notch out near the top, and then I took a sturdy pin and poked a hole. A push pin works great, and for those of you stopping by the office looking for eclipse glasses, we'll have pins and drink cups which you can use to make a solar projector. Once you've got this punched through and got your notch cut, I took the lid and I traced on a piece of paper, and then, I'm not sure if you can see this, I cut lots of little notches. And what I can do now, set the paper down and take the lid, press it down, voila. Now I see that, whoops, you might want to glue this together. I see that when I press this together, the bottom is a nice flat white screen. Sorry, fiddling with this a little bit. There we go. Try again. Got it. Now you can see inside, I hope, that the bottom is a nice flat white screen. The idea, let's say the sun is up here, I'm going to stand with my back to the sun. I'm going to point the bottom of the can with the hole, and it should project an image of the solar eclipse inside where I can see it. Now, once you do this, once again, you can also look at the image and then make a sketch on a separate piece of paper of what the solar eclipse looks like to you. If you don't have a convenient yogurt cup, cottage cheese tin, breadcrumb container, you can use a regular plastic red drink cup. I'll have a couple of sleeves of these in the front office with the eclipse glasses, and we'll also have a box of sturdy T-pins. These are nice and sturdy, and I can carefully take the cup, there we go, and put a hole in the bottom. Again, with a piece of notebook paper and pointing the base of the cup at the sun, I should project a nice solar image. The image through a pinhole camera such as this is going to be quite small. If you would like a larger image, then what you need is a fairly stiff piece of cardboard. I'm going to go ahead and use the cardboard cover of this notebook. What I can do with this, let me get a pen. What I can do with this is I can take a pen, a regular big pen, bang, and I've made a nice hole in the cardboard. Now, if I hold this up and allow the sunlight to shine down onto the sidewalk, the projection distance from the paper to the sidewalk will be 5 or 6 feet, and this will, believe it or not, make a very nice projected image of the solar eclipse on the ground. And again, you can take a picture of it with your cell phone, and you can have someone take a picture of you holding up your solar projector. The very last way to observe the solar eclipse is really special and lots of fun. We've all enjoyed the shade of a leafy tree on campus on a warm summer's day. Well, you may have noticed the dappled sunlight on the ground. The shade isn't perfectly dark unless the tree is very thick. What you may not have noticed is these spots of sunlight are all round. They're all essentially images of the sun. On the day of the eclipse, the ground underneath a tree won't be covered with round circles of light, but rather hundreds and hundreds of crescents, images of the sun projected through the gaps between the leaves. The tree itself and the gaps between the leaves work exactly like a pinhole camera, like our piece of cardboard or our drink cup, and it will project a nice image of the sun onto the ground. If you can find a place where the shade of a tree falls on the sidewalk, you should be able to take a picture of hundreds and hundreds of beautiful images of the solar eclipse. I would like you to see how many ways you can document the solar eclipse. Again, for those of you in outdoor education, intro to STEM, or astronomy for educators, this will be a regular class project for credit. For those of you in intro to education, I know most of you plan to teach young children, K through 6, but you'll also be teaching science. And I'm going to offer you the chance to document your solar eclipse and turn it in as an extra credit project. Look in your email for all the details. That's where you've got the link to this video, and you'll find precise information about the exact time the eclipse starts, hits maximum, and ends. If you want, I'd also be interested to see you take some pictures of the campus when the sun is at maximum solar eclipse. It looks very different. See if you can see any stars in the sky. Notice what the birds do, because birds' behavior and squirrels' behavior change when the sun goes down and the sky gets dark. Although we'll be at 92% eclipse, this is still not dark enough to look at the sun safely. You may say, oh, but it feels comfortable. It's dim enough I can look at it. But they're still getting ultraviolet rays, the same ones that give you a sunburn, can damage your eyes even when the sun is 92% eclipse. So remember, you only observe the sun directly if you have a pair of solar eclipse glasses. And for documenting the sun, you use indirect observation, such as projecting with a binocular, or a cup pinhole projector, or a tree solar eclipse projector. See how many of these you can document, and make sure you take a picture of yourself. Take a solar selfie documenting the solar eclipse. I look forward to seeing you as soon as the semester starts, and hopefully I'll bring back some exciting pictures from St. Joseph, Missouri of the total eclipse of the sun. Thank you. We'll be seeing you in class.